Hi everyone, my name is Ali Musa. Today I'm going to take you through some questions in calculations in respect with the C2. You know very well C2 you are being tested in a single phase, and you know very well in a single phase you are required to know that you are required to build or to do your electrical works or to give you experience in electrical works from ground floor to second floor. That's where your license is being entitled to do electrical works. And without forgetting, you know Kenya, we are being given 240. We are being supplied as a consumer. We are using 240 for our residential consumption. So in your license as a technician who wants to be licensed, you need to know these concepts, and you need to know these things before you are going to sit for your exams. Before you sit your exams, make sure you know these topics and you know these simple calculations, like you must know calculations from power. You will be tested either from power, you may be tested either to calculate power, to calculate voltage, to calculate resistance, to calculate current. So you need to know these things before you go and sit for your exam. And these things are very simple. It's very simple to pass, and it's very easy to fail these exams. But I know most of you have passed these exams, and it's not a very big miracle that you are going to fail your exams. But I know 98% those who have taken these questions very seriously, and those who have revised very well, they will enjoy the atmosphere, and they will enjoy the climate, they will enjoy the paper, and things will run very smoothly. And today we are going to tackle about calculations of power, current, voltage in low voltage circuits. Because in our class C2 we are being tested in low voltage. We are not entitled. If you will see your paper asking you about three-phase or high voltage, note that there is an error. There is an error, but as an electrical man or as an electrical ready, you must tackle that question, because they know that you have your know-how on how how to tackle these questions. So briefly, we are going to talk one by one: power, current, voltage in respect to with low voltage. So in exams, you can be asked a very simple question to calculate power, or to find voltage, or to find even current. But sometimes as I've told you, you can go to exam and you cannot find these questions, but you find what we call a table, a very simple table. So today we are going to start with a table. Then how you are required to fill your table on 30 exams. So without wasting a lot of time, let us start with first of thing. Let us start with writing some simple formulas which will assist us to calculate these things. So formula number one, which we are going to use, is that and you will see how we are going to use it. Formula number one is power is equals to VI, where P is power, V is voltage, R is current. This is Roman 1. Number 2, you are going to see where we will apply this one. V is equals to I R. V, as we have stated earlier, V is voltage. I is current. R is resistance. So you must know these things and their SI unit. SI unit for power is watts. SI unit for voltage is volts. SI unit for current is amperes. As we have said, SI unit for voltage is volts. SI unit for current is amperes. SI unit for resistance is ohms. So let us draw a very simple table. We try to fill it. Then we will continue with other questions. So when I've said this, when I've stated this way, you know very well. Without being told, I is equals to V divided by R. Without being told, you make I the subject of the formula. And number 4, if you need to get resistance is equals to resistance is equals to V divided by I. So you need to have these things in your fingertips before you go to that hall where you will sit and tackle your paper. So you need to have these things on your fingertips, and before you start your exams, start with these simple things. So you will get this table. You will get a very simple table like this one. In this space, you have been given power, current, voltage, and resistance. And in this column, you have been given power, voltage, power, current, and resistance. Already you have given those. You have been given those numbers. You have been told to fill the space. So like this one, you can see this is an empty space. This is an empty space. This is an empty space, and this is another empty space. So you can check very well. In this line, you have been given current, you have been given current, you have been given resistance, but you have not given voltage. You have not been given this one. Remove this one. You have not given, so yeah, you have not been given this. So in power, you have not been given this. These are blank spaces where I have dotted X. You have not been given those area. So you have been told. No one in that room will tell you to fill the gap, but you've been told to find the missing voltage, current, power, or the resistance. We have seen we have been given current and we have been given resistance. So already we know V is equals to IR. Already we have current 4 and we have resistance 2. So our V is equals to 6 volts. So we will replace this one with 6. And this table, I must tell you for free, it comes with a mark of the marks awarded this table is 12 and above. If you may get an opportunity to get this 12, I can tell you for free, already you have passed the exam. Already we have gotten 6, and the power, we know power is equals to VI. So V is 4, and V is 6, and I is 4. So 4 times this one is 24. Already we have secured our if is 2 marks. Already we have secured our marks. Here we have not been given current, but we have been given voltage, we have been given resistance. So we have not been given current, and we know current is equals to VI. V is 3, and V is 3, and resistance is 6. So this is 1 all over 2. So this is 0.5. This SI unit is amperes. And we have not been given power. Power we know is V times I. V is this one, and V is this one, I is this one. So it's 1.5 times 3. This is all over 1. This is 3 over 2. This is 3 all over 2. Already we have gotten that one. And this one we have not given R, and R we know is equals to V over I. V over I, that is 2. This is 2, and the power is equals to IR. This is 2. You can see how it is very easy to fill this table. Here we have not been given power, we have not been given resistance. So resistance we know is equals to V over current. V over current. This is 6 divided by this one. This is 3. And the current we know, power is equals to V times I. V times I. This is 6 times 2. This is 12. 12. That's how it's very easy to get the marks from this table. or they can change this table in this form. They may change, not they may even change, they change it. They rotate the table, but even though they rotate the table, the result remains the same. The result remains the same. They can change like this way. So our table had power, voltage, current, resistance. So they can rotate the table to read it this way: power, voltage, current, and resistance. Okay? Even though they change it, even though they change your exam in this format, don't panic. Alright? Don't panic. The results remains the result. Without wasting a lot of time, let us go straight to tackle Evel. At least we do 3 questions in Evel. So we are going to start with power calculations. Power we are going to start with power, and we know SI unit for power. SI unit is watts. So we are going to do in every unit 3 questions each. Then we conclude our lesson today. So our first question, you are being asked at 240, calculate power where at 240, at 230 volt heater draws a current of 12 amperes. Epra always ask a very simple questions. They don't ask a very hardest question. They ask very simple things. So you are being asked to calculate power where an heater is being using 240 with a current of 12 volts. So V, we have been given V is equals to 230 volts. Current with a current of 12 amperes. We know power is equals to VI. Alright? So it's 230 times 12. 230 times 12, which comes to 2760. 2760 watts. This is 2760 watts, and we can change it to be you can change this one to read like 2.76 kilowatts. I hope I have not broke the 10 commandment of electrical. If I write this way,